discussing? Does anyone remember where we were last time? What we covered?
Derivation of formula to find consecutive numbers.
So how do we derive? So we were trying to derive sum of the first 10 numbers, right? Because we assumed in the derivation of the volume of the cone, what sum did we need? We need something. What sum did we need for that? We had some formula. Does anyone remember that formula? It was not sum of the first 10 consecutive numbers. That was needed for area of triangle. For the volume of the cone, we needed something else. Does anyone remember what we needed and what was the formula?
Consecutive square numbers.
Square numbers.
Sum of the squares of the first n numbers. And what does anyone remember the formula for that sum? Who remembers the formula for for that 1 squared plus 2 squared plus 3 squared and n squared?
6n n plus 1 2n plus 1.
Repeat that again, sorry, just once more. Just tell me again.
1 by 6n n plus 1 2n plus 1.
Yes, correct. Good. Now, so we just assumed that, right? We didn't know how to do it. So let's go back to now deriving that formula. But let's first understand how to get just the sum of the first n consecutive numbers without the squaring. So let's look at just 1 through 100. Let's take 1 plus 2 plus 3 till 100. Okay. Let's try to understand how to get the formula for that. And one hint I want to give is you try to reverse flip it. So remember, it is connected to the area of the triangle, right? So in the area of the triangle, now remember how you can get the area of triangle easily without trying to do this first n sum. You take the triangle and you look at the rectangle. You take the triangle and you will see a flipped rectangle. So, and then you put them together, you get the you take a flipped triangle and then you put them together, you get the rectangle. So in that same way, you can take this 1 to 100, 1 plus 2 plus 100, you can flip it, and then you have to see somehow it is like a rectangle. Does that hint make any sense to anyone? From that hint, can someone tell how to get 1 plus 2 plus 3 to 100? Okay, so let me do it here. Let me try sharing it here. So we want to do, let's say, 1 plus 2 plus 3. Can you see this? Can everyone see this?
Yes, sir.
Yes, sir.
Okay. Do this sum. And to get this sum, I want to suggest that you look at the what we did for the triangle area.
N plus 1 divided by 2, sir.
Yeah, no, but that is a formula. But I'm trying to derive that without. Yeah. So that formula that someone mentioned, that you were just told that formula, right? You were not shown why that formula is correct. So here we are now trying to get that formula. We are trying to derive the formula as if you didn't know that. Okay. So let's start just with first 100 numbers. 1 through 100, 1 plus 2 plus 100. And to get this, I want to suggest, think about how the area of the triangle is done without summation. Okay, so let's look at a triangle. Now think of the simpler derivation for area of triangle. So this is the triangle. Why do you know? And let's say this is 100 by 100. Okay, this is also 100. This is also 100. So actually, it's a square. Now think of why. How do you get the simpler derivation for the area of the triangle when it is 100 by 100? Do you remember the simpler derivation without doing 1 plus 2 plus 3 plus 100, without doing all that?
Half of base into height, sir.
Yeah, but what is the derivation for that?
Area of square divided by 2, sir.
Yeah, why is that the case? How do you know that?
The diagonal cuts the square into 2 equal congruent triangles.
Exactly, yes. Okay. So, or another way you can think of it is that, let me tell you. Another way you can think of this is you have this one triangle, okay, and you have flipped that triangle. You have flipped it to get this triangle. Because if I take this triangle and flip it around the vertical axis like this, so I flip it like this, I will get exactly this triangle. And now when I put these two together, it becomes the square. And now notice each column here. Okay. Now go back to the grid idea. So let me put back the grid. So get rid of those lines. So this. So lots of such grids. Now remember we had the steps here. Instead of taking the exact diagonal, we're taking steps. So if you look at the steps, then the below that steps, there was one step here in the first column, so 2 steps in the second column, 3 steps in the third column, so on and so forth, so on and so forth. So it was getting 1 plus 2 plus 3 plus 4. But now you look at the flipped triangle, then this had 1, this step had 1 here, and this had 99. And this had 2, and this had 98, and so on and so forth. And that's why when you add them up, you get exactly the same number of tiles in each column. Okay, so that means if I take this and I flip it and somehow add them up, I get the same number of tiles. So can we apply the same thing? So we want to get this sum. Okay, let's call it x. And I can also flip it. I can also say x is equal to the flipped one. So let's put the flipped one above it. Exactly the original triangle plus the flipped triangle. So the flipped triangle series is 100 plus 99 plus 98. Now, can someone use this idea here? Look at this idea, how we are getting the area of the triangle. So we're flipping it and we're looking at, thinking this forms a rectangle. That means each column now has the same number of tiles. Can someone use that idea to see how to somehow put these two together and get a formula for get a easy way answer for 1 plus 2 plus 3 till 100? You can think that this is the number of tiles in the first column, this is the number of tiles in the second column, this is the number of tiles in the third column, and so on and so forth. And then you have a flipped triangle, and then this is the number of tiles in the first column of the flipped rectangle, this is the number of tiles in the flipped thing in the second column, and so on and so forth. So actually here there is 1 in the lower one and 99 in the upper one, 2 in the lower one and 98 in the upper one. But it's almost similar to this. So does someone get any idea how to add these two? If I add these two, what will I get? So the hint is to look at this and also look at this. Look at this and look at this and see. Here we are getting a simple formula for area of the triangle. And here we were trying to get a formula for 1 plus 2 plus 3 100. Anyone has any idea or needs, or do you think you need more hint? Okay, so this is the steps. Okay. And then I want to say, so this is the main triangle, and this remaining is a flipped triangle. And you notice that there is 1 tile here, 2 tiles, 3 tiles, 4 tiles. And the flipped one here has 99 tiles here, 98 tiles here. So think that is 100 by 100. So this has 99 tiles, 98 tiles, 97 tiles, and so on and so forth. But when you put them together, you get all 100, 100, 100, 100, 100 tiles. So look at that idea and tell me here. You can think of the first formula as the flipped, first sum as the flipped triangle, which is this flipped triangle, and the second one as the main triangle, which is this triangle. Now, does someone have any idea how to add these up and get a simple formula, simple, easy thing which doesn't involve a big summation? Just look at each column, look at each position here. The same position, when you add up, what do you get? The first number in both of them, the second number in both of them, the third number in both of them. What do you get? Okay, let me just pick some person. Bhumika M. Lonar. Bhumika? Yeah.
Yes, sir.
So do you see the, what are we trying to find? Can you just repeat what are we trying to find? Which sum are we trying to find? Yeah, Bhumika, I think you have muted again. Can you unmute and tell what sum we are trying to find? Sanjana?
Yes, sir.
Okay. So can you unmute? It's still mute. When you talk, it unmutes, but then it goes to mute again. So is there a way to keep it unmuted?
Yes, sir.
Okay. So can you tell what is the sum we are trying to find?
The sum of consecutive numbers, sir.
Yeah. And specifically here we are trying to find up to which number?
Up to 100, sir.
Yes. So we are trying to find this sum, right? 1 plus 2 plus 3 till 100. Okay.
Yes, sir.
And we don't want to use the formula because we think that we don't know the formula yet. That n into n plus 1 by 2 we don't want to find. Okay. Now, Sanjana, this upper thing that is written, okay,
Yes,
how
sir.
is that different from the lower one? Is it the same or is it different? Look at the upper sum. The upper sum is what? Can you read the upper sum?
Yes, sir. X equals to 100 plus 99 plus 98 plus up
Yeah.
to 1, sir.
Yeah. Is that same as 1 plus 2 plus 3 till 100 or is it going to be different?
Same only, sir.
Yes, it is same. Why? Because the same number, exact same numbers, but it is reversed. So the upper thing and the lower thing are the same thing. Now, to find that, let's just add up both of them and see if we can simplify. Okay. So I want you to try to add the upper thing and the lower thing and see somehow if it becomes very simple. Do you see any way of adding them up and ordering it differently so that it becomes very simple? You can say yes or no, Sanjana. You can say no if it is not, if you don't see a way. Yeah, you can say no if you don't see a way, Sanjana. Okay. Sanjana, do you see this figure here? This square here?
Yes, sir.
Yeah. Now tell me, look at this thing below the diagonal. Okay. Now this thing below the diagonal, there is one tile here, and then 2 tiles here, 3 tiles here, and so on and so forth, right? So this is 1 plus 2
Yes,
plus
sir.
3 plus still 100. Okay. Now look at the flipped thing. The flipped thing here is, the upper thing is 99. This is 99 tiles in the upper part. This
Yes,
is
sir.
99 and this is 1. So together it becomes 100. This is 2 here and 98 here. So 98 and 2, it becomes 100. This is 97 and this is 3, it becomes 100. So this sum of the upper triangle is 99 plus 98 plus 97, so on and so forth. And this is, lower one is 1 plus 2 plus 3 plus so on and so forth. But when we put them together, column by column, they become exactly same number of tiles. So is there some way to put these two things together so that column wise they become the same? Something becomes the same when you see this column wise. Tell me, Sanjana, what are the numbers in the first column when you look at both these expressions for x? What is the first number in the upper thing and what is the first number in the lower thing?
101, sir. First thing, the first number is 100, sir.
And
And in the second thing, 1 is the first number, sir.
yes, okay. So those are two numbers in the first column. Now think what happens when you add them up, okay? And now look at the second column. Now tell me what are the numbers and what happens when you add them up. What are the numbers in the second column, Sanjana? You're muted again. I think you have to unmute and then talk. Yeah. Again, you're muted. Can you unmute? Something is happening.
98 and 2, sir.
Is it 98 and 2? Is it 98? The second number?
99 and 2, sir.
Yes. Now think what happens when you add them up. And then go to the third column and again add them up. And fourth column and again add them up. Tell me what will happen.
Sum is
97
not
and
1.
4,
Sir.
sir.
Tell clearly again.
97 and 4, sir.
Yeah. So what happens when you add up these each of these pairs? So it's in the first column it is 100 and 1. Second column is 99 and 2. Third column it is 98 and 3. What happens when you add them up? Each of these pairs.
101, sir.
Yeah. Is it going to be 101 in every column if you add them up? Is it going to be 101?
Yes, sir.
Sanjana? Why is it going to be 100 in everything? Why is it going to be 101 in everything, in every column?
The first thing is 100 in and below ones 1 is the first number, sir. 100 plus 1 is equal to 101, sir.
Yeah. And then second one?
Second one is 99 plus 2, sir. It is also equal to 101, sir.
Yeah. So
Then
the first two
98
are
plus
both 100. Yeah. Now, why is it going to be 101 everywhere? So we are seeing that the first three are all 101. Why the fourth one, fifth one, sixth one, everywhere it is going to be 101? Think about this. Think about this square. You can figure out from the square also, or even from here. Okay, I see someone has raised hand. Sahana Benny, do you want to try why is it going to be 101 at every column?
I have taken 100 as n. So then 99 as n minus 1, sir. It will continue till n minus 99, sir. Then again in below I have taken n minus 99, sir.
Okay.
So here we have taken n equal to 100, no, sir. So 1 is n minus 99, sir. So if we add n 100 plus 1 means 100 I have taken n, sir. So n plus 9.
Your thing got muted, Sahana. Somehow it got automatically muted.
If we add n plus n minus 99, we will get 2n minus 99, sir. We have taken n equal to 100, no, sir. So 2 into 100 minus 99, that is 200 minus 99, that is equal to 101.
Okay. So why is every column? So first column I can see it is 100, which is n, and the lower one is 1. So I can see n plus 1 there. Why is every column going to give 101? Let's take the ith column. The ith column. The ith column. What is the value in the lower sum? Sahana?
What, sir?
If I take the first column, then the lower thing has 1 there. The second column, the lower thing has 2 there. The third column, the lower thing has 3 there. Okay. The kth column, what is the value in the kth column in the lower thing? In general, the kth column will have lower sum will have. So the simple reason why you will get 101 is because every time.
99.
How much is it, sorry?
2 times of k minus 99, sir.
So tell me in terms of n. If you're using n for 100, in general, tell me the upper thing what it will have and lower thing what it will have. If you're using n, then don't use the word 99 because 99 is just n minus 1. So what will the upper one have and what will the lower one have?
Don't know, sir.
The lower one will have k, right? Because we'll have in the kth position, we'll have k. Upper one has What is that it had in the first position? It has 100. Second one, it has 99. Third one, it has 98. So in general, it will be, will it be 100 minus k? Is it going to be 100 minus k or is it going to be 99 minus k? Will it be 100 minus k? The first position 100.
Yes,
Right?
sir.
So will
Yes,
it be
sir.
100 minus k? But the first position, if I put k equal to 1, I get 99 according to 100 minus k. But actually it is 100. So will it be 100 minus k or 101 minus k?
101 minus k.
101 minus k, sir.
Yeah. Okay. I mean, you don't even have to do this k and 100 minus k. The main thing to note is that here it is 100. In the first column, it is 101. In the second column, this one, upper one decreases by 1, the lower one increases by 1. So every time the upper one decreases by 1, the lower one increases by 1. And because they always decrease by 1, increase by 1, the increase or decrease cancel out, and that's why it always stays 101. So that is a simple reason why this everything will become, every sum will become 101. So now if we add this up, what do we get? We get that 2x, x plus x is 2x, equal to what? 101 plus, second column, if I add, what will I get? 101. Okay. Plus the third column will again become 101. Like this, what will we get all the way? The column will become what? Yeah. Okay. Now can someone complete from here? How to get 1 plus 2 plus 100? Can anyone complete from this point? Can you get a formula for 2x now? A simple expression for 2x?
So we have to add 101 100 times. So 101 into 100, sir. X equal
Exactly.
to 100 into 101 divided by 2, sir.
Exactly, yes. So 2 times x is equal to 100 times 101. And so capital X is equal to 100 times, I'll just put a dot for multiply, 101 divided by 2. Okay. Now
Yes, sir.
from here, now tell me, how do you get a general formula for n, 1 plus 2 plus n? Can someone tell me how to get? How should I change this to get general formula? What should I do here? Who wants to? Can someone
n bracket n plus 1 divided by 2.
N bracket n plus 1 divided by 2.
divided by 2, sir.
Yeah, I want to go through the steps, each step. Okay, I want to derive it. Can someone volunteer? Who wants to volunteer? Can someone raise their hand to volunteer? Anyone wants to volunteer for the n, in general, the n case? 1 plus 2 plus is still n. To change these lines here. Someone who spoke, just raise your hand. Whoever spoke that thing can raise your hand, and we can walk over this. A lot of people were saying and speaking just now. Can one of you raise your hand? Okay, I see one hand raised. Mahalakshmi. Okay, Mahalakshmi, you can unmute and then tell me how I should change
Sir,
this.
we can take 100 into 100 and 100 plus 1 by 2.
Yeah, that is for 100, right? That is for 1 through 100. Now, that was in this slide. Second slide, I did that. Okay. Now, in third slide, I want to now change this from 1 to n. So tell me what all changes I should make here.
Sir, let 100 is equal to n, sir.
Equal to n. Okay. So how will I change this?
100.
These two lines here. Let's go line by line. Let's go step by step. So this was the sum we want to find, right? This second line. This one, the second line. What should I change this here? Instead of 1 plus 2 plus 3 till 100, what should I do? Change this to 1 plus 2 plus 3 till n. Okay, and instead of 99, it will become n minus 1. It will become 1 plus 2 plus 3 like this. Now tell me, how will this upper one change?
So can
Who
I?
was helping?
n plus n minus 1, n minus 2.
Exactly. So Instead of 100, it will become n. Okay. Instead of 99, it will become n minus 1. Instead of 98, it will become n minus 2. Like this, plus, 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 all the way to 2, and then plus 1. Okay. Now, Mahalakshmi, can you tell me what will happen when you add them column wise? The two x's. What will I get in third line?
So n plus 1, n plus 1, n plus 1.
Exactly. Okay. So the first column I will get n plus 1. Okay. Second column I will get n plus 1. Okay. Same thing all the way to. How many times will I get n plus 1? How many times will I get n plus 1? Yeah. Who was talking? Can you speak up? Mahalakshmi, you were talking, right?
Yes, sir.
Yeah. How many times will we get n plus 1?
So 100 times. N times.
Yeah, not 100. I mean, now there is no 100. It is n. Okay. So how many times? N times.
Yes.
So this will become. So what will it become here in this line?
N into n plus 1.
Exactly. Okay. So 2 times x is equal to n into n plus 1. Tell me what happened in the last line.
So n into n plus 1 by 2.
Exactly. And now in general, the lower part, the kth number will be k. And the upper part, the kth number will be what? What is the kth number? So the first number is n. The second number is n minus 1. The third number is n minus 2. The kth number is what?
N plus 1 minus k, sir.
Exactly, n plus 1 minus k. Okay, it is not n minus k. If it was n minus k, then the first number would be n minus 1. It is n plus 1 minus k. Now, Mahalakshmi, can you tell me how is this derivation similar to this area of the triangle? The simpler method for the area of the triangle, where we are taking this triangle and the flipped triangle, we are putting them together. How is it similar to that? Whatever we just did for finding 1 plus 2 plus 3 till n.
Sir, repeat.
So what did we do? We took 1 plus 2 plus 3 till 100 and we flipped it, or 1 plus 2 plus 3 till n, and we flipped it, right? We flipped it means we reversed it. We reversed it and then we added it column wise. Okay. And when we saw that by column wise, each column became the same. Now tell me, how is that similar to in this slide when we are looking for the area of the triangle, this lower triangle? Okay. Now you look at this area of the lower triangle and you flip it and you see this upper triangle. And now when we put these two upper and lower triangles together, we get a square. Tell me, how is this area of triangle thing here similar to the derivation of 1 plus 2 plus 3 till n? Do you see any similarity between the two things?
It is increasing or decreasing in such manner.
Yeah. Who spoke just now? Was it Mahalakshmi or was someone else?
Farhan, sir.
Can you raise it? Farhan, okay. Farhan. So can you tell me, like, if someone doesn't, you're trying, suppose someone doesn't know how to derive formula for 1 plus 2 plus 3 till n, okay? How can you give that person the idea or a hint to derive the formula by saying, think about the area of a triangle. Think about how two triangles become a square. Can you think how to give that hint to someone? How will you look at two triangles, they become a square, and use that to give some ideas about how to get 1 plus 2 plus 3 till 100 or 1 plus 2 plus 3 till n? Farhan? What will you tell that person? If you want to teach someone how to get an idea for 1 plus 2 plus 3 till 100 by saying, look at the triangle, area of a triangle, look at how the triangle is half of the square. How will you tell that? Farhan? Any idea? Or anyone else? Anyone else has any idea how to tell that? Anyone else can explain the exact similarity between why the area of the triangle being half the area of the square is similar to the derivation of the formula for 1 plus 2 plus 3 ln. Pavitra Dugani, do you want to try? Can you unmute, Pavitra? Okay, let me try. Okay, how about Madhumita? Madhumita, are you there?
Yes, sir.
Yeah. So, Madhumita, did you understand the derivation for 1 plus 2 plus 3 till n?
Yes, sir.
And do you see any similarity between that and the fact that a triangle is half of a square? The two same triangles become a square. Do you see any similarity between the two things? The derivation and this one? You can tell yes or no. You can tell no also. Don't worry about. Don't hesitate to say no that you don't see similarity.
No, sir.
Okay. Do you see this? Do you see this lower triangle here?
Yes, sir.
Okay. And do you see this upper triangle here? Upper triangle
Yes,
here.
sir.
Do you see that the upper triangle can be thought of as reversing the lower triangle, flipping it, reversing it? Is this reverse of this triangle? Do you see that?
Yes, sir.
Okay. So this reverse triangle and this main triangle, they are both identical. And if I flip it and I put them together and look at each column wise, every column has the same height. Correct?
Yes, sir.
Now, what is going on here? You can think of this thing as the main triangle and this upper one as the reverse triangle. And now you put them together and every column has the same value. What did you understand? Does that make sense? Does that make sense? Okay, let me try. Sahana Benny, do you want to try unmuting?
Yes, sir.
Yeah. Did that make sense? What I just said, Sahana?
Sir.
Was that understandable?
No, sir.
No? Okay. So what I'm trying to say is, look at this triangle. Do you see this triangle, lower triangle?
Yes, sir.
Okay. And do you see the upper triangle?
Yes, sir.
Okay. Can I say that the upper triangle is reverse of the lower triangle? Is it the reverse of the lower triangle? Because in the lower triangle, this last column is biggest. In the other triangle, the first column is biggest. And whatever columns I get, like as it is increasing this way in the lower triangle, it is increasing if you go in the opposite direction. So can I say the upper triangle is like reverse of the lower triangle?
They are inversely proportional, sir.
Repeat that, please.
The triangles are inversely proportional, decreasing or increasing, sir. The lower triangle is increasing, sir. That upper triangle is decreasing.
Exactly, yeah. So whoever just spoke, do you see why that same thing is happening in this proof here? Here again, the lower one, it is increasing. The upper one, it is decreasing. And then when you add it together, they become the same everywhere. Okay? Here also, when you put them together, they become the same everywhere, every column. So do you see that the same thing is happening here?
Yes, sir.
Okay. So that is how the proof of the area of the triangle, that two congruent triangles make a square, and can be used to get this sum formula for 1 plus 2 plus 3 till n. So did everyone understand why we get n into n plus 1 by 2 for the sum of the first n numbers? Did everyone understand that?
Yes, sir.
Yes,
Anyone
sir.
who did not understand this derivation? Anyone did not understand this derivation? Can raise hand, and I can help. Everyone understood?
Yes, sir.
Samiksha
Yes, sir.
Chorlekar. Let me ask some random people. Samiksha Chorlekar, did you understand? Yes.
Yes, sir.
Okay. Shravan Kumar, did you understand? Understood? Shravan Kumar? Okay, I don't hear the response. Sujata, did you understand? Sujata Mailari, did you understand?
Yes, sir.
Okay. Okay, so looks like you have understood this formula. Now let's go to the next thing, which is the sum of the squares of the first n numbers. Okay, so make sure you have understood this thing. Why this sum of the first n numbers is. Now let's go to the sum of the first square of the first n numbers. Sum of square of the first n numbers. So let's try. So let's say, so we want to do what? 1 squared. And since I'm typing it in text, I'll just put caret means squared, okay? Plus 2 squared plus 3 squared. And let me do the same with till 100 squared. So this is what I want to find, right? But now can I do this reverse thing and just adding it up and say that it's the same? Can I do that? Can I say that if I take 100 squared plus 1 squared, and then 99 squared plus 2 squared, will I get the same thing? Can I do like that same thing? Add up with two things column wise, and will I get the same thing? Will that idea work, or it will not work? Can I do this reverse and then add it up? Is 1 squared plus 100 square same as 99 squared plus 2 squared?
Yes, sir.
No, that's right. It's not the same. Actually, it will go on decreasing. 1 squared plus 100 square is 101. Sorry, it's not 101. 1 squared plus 100 square is 10,001.
1001.
No, 10,001. What is 100 squared? What did you say? Who said? Someone said something. How much is it? How much is 100 squared?
10,000, sir.
Yeah, 10,001. So the first column will become 10,000 plus 1 squared, which is 10,001. The second column will be 99 squared plus 4, but that is actually less than 10,001. Okay, so as you go on more, it will become less and less. So that idea doesn't work. Does someone have any other ideas? Don't do the reversing. Do something else. Okay, so let's not do this reversing. Let me remove all this. Any other idea someone has? Think for a minute, someone. If someone has any ideas, that will be very nice, because this is like, now you're thinking about how to derive these formulas. Think about the first person who must have derived such a formula. So there must have been some point in history where people were thinking how to get a formula for 1 plus 2 plus 100, right? And then somehow by this reversing and adding, they must have got this n into n plus 1 by 2. Okay, must have been thousands of years ago. Thousands of years ago, someone must have got this formula for this, what we just derived here. Okay, this n into n plus 1. And then after that, someone must have thought, now how do I get a formula for 1 squared plus 2 squared and n squared? Okay, and they might have tried, okay, let me reverse and add, it doesn't work. So then someone must have thought of some other better ideas. So if you can also think like that and get some formula for this, that'll be like you're thinking like a scientist who's coming up with the first, or a mathematician who's first coming up with the formulas. So think for a minute and see if you can come up with some nice ideas to get this. And if anyone has any ideas, you can, even if it is not a complete idea, even if you think maybe something like that could work, just raise your hand and tell your idea. Tell what you think might work. It doesn't even have to be a complete idea. Even a rough idea might work. You can tell. Anyone has any rough ideas? Maybe try writing the squares as a sum and then rearranging. You can see if somehow by rearranging. So what had we done in the previous one? We took 1 plus 2 plus 3 till 100 and we reversed it and then we rearranged it and so it becomes all 101, 101, 101. Here, can we do something like something, like 2 squared is just 2 plus 2, 3 squared is 3 plus 3 plus 3. Can I do something like that? And then try to rearrange? Anyone? Anyone has any thoughts? How can I write each of them as a sum? How can I write 2 squared as a sum, 3 squared as a sum? What is 3 squared? As a sum.
3 into 3 is 9.
Yeah. But can I write it as a sum?
3 plus 3 plus 3.
3 plus 3 plus 3.
3, sir.
Yes, exactly. Okay. And 2 squared is?
2 plus 2 plus 2.
2 plus
2 plus 2, sir.
4 squared is 4 plus 4 plus 4 plus 4. So I can write each term as a sum like this. Now think, so I'm getting one term in the first, so 1 squared is just 1. 2 squared is 2 plus 2. 3 squared is 3 plus 3 plus 3. So I'm getting 3 terms in the third thing, 4 terms from the fourth thing, 100 terms from the 100th thing. Okay. Now think if I can rearrange this thing in some way. So what am I doing? I can write it as 1, okay, plus 2 plus 2, okay, plus 3 plus 3 plus 3, plus 4 plus 4 plus 4 plus 4 times. Okay, like this. Right. Now think how to rearrange this, right? Put it in some nice order. Maybe I can write the 2 2s in some vertical order or 3 3s in vertical order and try to imagine it in a nicer way. How will I rearrange these numbers? Anyone has any ideas for how to rearrange these numbers? Can I put them in some like triangular order? So I have one term followed by 2 terms, followed by 3 terms, followed by 4 terms. Can I put them in some triangle? How will I write this as a triangle? Write in some triangle form. So let's put, say I have 1. Let me write 2 plus 2 below it. Okay. 2. Okay. And then 3 plus 3 below it. 3 plus 3 plus 3. And then 4 plus 4 plus 4. I'm just writing it in vertical order like this. And then eventually I'll have 100 plus 100 plus 100 like this, 100 times. Does this look like a triangle? This like a triangular order from here to here?
Yes, sir.
Does it
Right
look like a
angle triangle.
Yeah. Now looking at this triangle, does anyone have any ideas how I can get this sum? How can I add this? A simpler way to adding up all these things.
When we add these numbers, sir, we will get the squares, sir.
Yeah. So now we are trying to get a formula, right? Or we are trying to get a formula, right, for n in general. So how do I get a formula by looking at this order? How should I be? So I've already rearranged it so that I can put all them in a triangle like this. So after putting a triangle, what do I do? What should I do after this? To simplify this or to somehow get a formula out of this? Or how do I get a formula for 1 plus 2, 1 squared plus 2 squared till 100 till n squared out of this? Think about adding it column wise. I have here in the first column, what do I have?
1 plus 2 plus till 100.
Yeah. And for that, we already know a formula, correct? So we can
Yes, sir.
reuse the formula for the 1 plus 2 plus 3 length. We can reuse. We already have derived that formula. So we can reuse that formula. So I can use a formula to now to do this. Can I use the formula for the second column? What is the second column?
So 1 minus n bracket n plus 1 divided by 2.
1 minus, is it 1 minus that or is it n into n plus 1 divided by 2 minus 1?
So
Is it 1 minus that or it is you subtract 1 from n into n plus 1 by 2. So it will be n into n plus 1 by 2 minus 1. So it is exactly the first one but without 1. What is the second column? First just tell me it as a sum. What is it? It is 2 plus 3 plus 4 till 100. So it is only missing 1. Okay. So it's 2 plus 3 till 100. Is there a simple way to write what is 2 plus 3 plus 4 till 100? Can we get that using the formula? Using the n into n plus 1 n into n plus 1 by 2 formula?
100 into 100 plus 1 by 2 minus 1.
Exactly. Okay. So let me just make a copy of the slide. So this is what you're trying to do. So first column is 100 into 100, 100 into 100 plus 1 by 2. Second column is same thing but minus 1. The general formula for the every column. Third column is same thing minus
2.
minus what? 2. Third column is what? 3 plus 4 plus. Yeah, what is third column?
Minus 2.
100 into 100. 100 bracket 100 and plus 1 divided by 2 minus 2, sir.
Is it
So
minus
minus 3. So minus 3.
Yeah, why is it minus 3? Why is it minus 3 and not
So
minus
in
2?
second are 2 and in
So 1
first are
plus
1.
2 is 3, no, sir. So minus 3.
Yeah. And so it's 1 minus 1. It's minus 1 plus 2. Okay. So it's not minus 2, it's minus 1 plus 2. Okay. And someone tell me a general formula for the kth column. What is the general formula for the kth column? So it will be 100 into 100 plus 1 divided by 2. And what should I do minus? What should I minus from here? Will it be just minus k? Will it
So
be
1
minus
plus
k?
2 plus 3.
1 plus k, sir.
Yeah, 1 plus 2 plus 3 till what? So I have to remove 1 plus 2 plus 3 all the way till what?
K.
The kth one.
K, sir.
Will it be till k? For the first column, are you removing 1 in the first column?
No, sir.
Yeah, so till where will I
No,
remove?
sir.
So it will be 1 plus 2 plus 3 till where?
Till 99.
No, for the kth one. So let's say I'm like case 5, let's say. So it will be 100 into 101 plus 1 divided by 2 minus 1 plus 2 plus 3 plus till where? For the fifth one, will it be till 5? Should I be removing 1 plus 2 plus 3 plus 4 till 5?
Till 100.
No, tell me for the fifth column. For the fifth column, tell me what is the sum? So first column, second column, third column, fourth column. Fifth column will start from where? First column starts from 1, 1, 2, 3 till 100. Second column is 2 plus 3 plus 4. Third column is 3 plus 4 plus this. Kth column is starting from? Fifth column is starting from where?
So 5.
5, exactly. So it will be 5 plus 6 till 100. So how much, what should I remove? So this from the whole sum, 1 plus 2 plus 100, what should I remove? What all should I remove? 1 plus 2 plus 3 till? For the fifth one, I should remove till 4 or till 5? For the fifth column, should the thing in the subtracting thing will be 1 plus 2 plus 3 plus 4? Or will it be 1 plus 2 plus 3 plus 4 plus 5? Should I remove 5? For the fifth column? Am I removing 1 for the first column? Or is 1 is there in the first column?
1 is there, sir.
Yeah. In the second one, am I removing 2 from the second column or I'm only removing 1?
Only 1, sir.
1, sir.
Only 1.
Yeah. So tell me for the kth column, what all should I remove? 1 plus 2 plus 3 till? Should I remove till k? What will be the last
So
number?
k
that I should be
minus
removing?
1.
Yeah,
K
exactly. I
minus
should be
1.
removing to k minus 1.
K minus 1.
Yes. So the kth column is this. Now, is there a simplified, simple formula that I can put for this? We already know a formula for 1 plus 2 plus 3 till k minus 1, right? We already know the sum of the first k consecutive numbers. So I can just get that formula for this. But I think you have you have some other thing now, right? You have some mentor thing now, right? Is that right? You have a mentor meeting now?
No, sir.
Oh, you don't have? Okay. So let's just continue for few more minutes. Okay.
Okay,
So
sir.
for the kth one, I will be doing k plus 1 plus 2 till 100. So that means I have to remove the sum of the first k minus 1 numbers. Now, can we use the formula to simplify this? What is the formula to simplify this? This is equal to sum 1 plus 2 plus 3 till k minus 1. 100 into 101 by 2 minus, what is this? What is 1 plus 2 plus 3 till k minus 1? Anyone want to say? We already derived the sum of the first 10 numbers, right? So what is the formula for
So
this?
k minus 1 into k minus 1 minus 1 whole divided by 2.
Okay, just repeat once more. What did you say? K minus 1. Okay. Into?
So k minus 1 into k minus 1
Into k minus 1. Okay. Into what? K minus 1. Okay. Then
minus 1
minus 1. Okay. Then
whole divided by 2.
you are saying k minus 1 into k minus 2 divided by 2? Will it be k minus 1 into k minus 2? This becomes k minus
Yes,
2.
sir.
Yes, sir.
Yes, sir.
So is 1 plus 2 plus 3 till k minus 1 equal to k minus 1 into k minus 2 divided by 2? Is that what you're saying? Let me try to understand. Okay, let me try to write something on the side here. So are you saying that sum of the first k minus 1 numbers is equal to k minus 1?
So no, sir. So k minus 1 into k minus 1 plus 1, sir.
Exactly. So that's the mistake. Okay, this is not right. It should be k minus 1 into k minus 1 plus 1. What is that? How much does that become?
K minus 1 into k by 2.
Exactly. So it is just k minus 1 into k by 2. That is the general formula. Okay. So now from here, know that the kth column will have this much. And we're going to add the first column, second column, third column, so and so like that. So what will we get now? We know that the kth column is this much. Okay, let me just. This is the general formula for the kth column. And now I have to add up all the columns. Add up all the columns. Okay. When I add up all the columns, what do I get? So I'll be adding up this 100 into 101 by 2 minus this for k equal to 1, then it's the same thing minus this for k equal to 2, and so on and so forth, so on and so forth. So by adding up all these, what do I get? Okay, so this is the general formula. So the first column will be, let me call it the first column as C1. Column 1 will be this thing 100 into 101 by 2 minus, for k equal to 1, this will be just be 0 into 1 by 2. Okay. The second column will be same thing. Just write it properly. 1 minus 1 into 1 by 2. Okay. Second one will be same thing, but with 2. 2 minus 1 into 2 by 2. And so on and so forth. So the 100th column will be the 100, which will be the same thing. Then I'll get 100 minus 1 into 100 by 2. Okay, is this clear? That first column we have a formula and we got exactly this. Second column we have this, third column we have this, and so on and so forth. Is that clear to everyone?
Yes, sir.
Okay.
Yes, sir.
Now we have to add up all these columns, correct? Is that right?
Yes, sir.
Okay. Now I can also write this, instead of writing into k minus 1 into k by 2, I can also write this as 100 into 101 divided by 2. Okay. And I can just take that k squared, k minus 1 into k, I can write it as k squared minus k divided by 2. Is that right? I can write it
Yes,
like
sir.
this, correct? Okay. So that means instead of 101, instead of this, I can just write it as minus 1 squared, okay, minus 1 divided by 2. And instead of this, I can write it as 2 squared minus 2 divided by 2. And so on and so forth till 100 squared minus 100 divided by 2. So by using
So
the
in
formula,
column
what we have
2, I
got.
have written.
Sorry, yeah, there's a 2 here.
So in column.
Yeah, okay. That's right. Thanks. Okay. So the first column is this minus this, and the second column is the same thing minus 2 squared minus 2 divided by 2, and so on and so forth. And if I add all these up, I will get exactly what? I will get the sum that we want. What is the sum that we want? We want exactly 1 squared plus 2 squared till 100 squared. So we want to find 1 squared. We want to find this 1 squared plus 2 squared till 100 squared. And it is turning out to be exactly equal to the sum of all these columns, which is this 100 into 101 by 2 everywhere, but minus 1 squared minus 1 by 2, minus 2 squared minus 2 by 2, and so on and so forth. Now, does someone have any idea how to complete from here? What will happen if I add up all these things? What happens if I add up all these columns, these expressions? Anyone has the idea? Adding up all the columns, we get what? I will add up, first of all, I'll add up all these. This 100 into 101 by 2, I'll get 100 times. Correct? So this sum I will
Yes,
get
sir.
100 times. So I'll just get 100 into 100 into 101 divided by 2. Correct? And then what will I get out of this? This part minus what? What I get from that part? Someone wants to try? What will I get inside that? I get something divided by 2, right? Let me it's something this 1 square minus 1 divided by 2, 2 square minus 1 divided by 2. So let me add up all those things. So I'll get this plus this plus this plus this whole thing divided by 2. What is that inside the bracket? What will I have to put inside the bracket?
So 1 square minus 1, 2 square minus 1, 2.
Exactly. So it will be inside that, it will be 1 square minus 1 plus 2 square minus 2 plus 3 square minus 3 till 100 square minus 100. Can we simplify that? Rearrange it and simplify that? What do we get? Can I collect the squares together and the individual and the non-squares together?
Yes, sir.
Yeah. Then what do we get? We'll get two sums, right? What do we get? You will get 1 squared plus 2 squared. So just gathering all the squares, I will get this thing. Okay. Minus, what should I put? Minus, which sum should I put?
So bracket 1 plus 2 plus 3.
Exactly. Till
100, sir.
100, sir.
exactly. Okay. So what did I get? So I want to get this sum. I want to get 1 squared plus 2 plus 100 squared. Okay, and I've got this for that sum. So I've got what? 100 into 100 into 101 by 2 minus the sum of the same squares minus the first sum of those 100 numbers divided by 2. Now this part we don't know. We don't know 1 squared plus 2 squared plus 100 squared. Is that right? We are trying to derive the formula. But this part I can simplify. This part 1 plus 2 plus 100 we know, right? Do we know this part?
Yes, sir.
Yes, sir.
What can I write there? So what can I write there?
100 into 100 plus 1 by 2.
Exactly. So I can just write here, I can just remove this and I can just say 100 into 101 divided by 2. Okay. Now from here, can someone tell me how to get the sum of the first 100 numbers squared? So remember, we are trying to get 1 squared plus 2 plus 100 squared. And we got this formula for it. But we can't go any further here because we don't know a formula for 1 plus 2 plus 100 squared. But in spite of that, we can get a formula for that. Can someone tell me how we get that?
So we can take the 1 square plus 2 square to the LHS part.
Exactly. Okay. So we basically what we are doing is we don't know what this is. We have an x for this, right? We don't know what this is. We have x. And I'm trying to get x and I got this formula for x. And I'm stuck here. I cannot go further. Why? Because I get that same thing here, but I don't have a formula for x. But I can just put x here. So I can just say that x is equal to this, which is equal to this, which is equal to put same thing x here. Okay. So now do you see why I can easily get x? So I can easily get x from here. Anyone wants to complete from here? How to get x?
Sir, we have to take the x to the LHS part. 2x is equal
Exactly.
to.
So, yeah. So what do we get? What do we get on the left hand side?
X plus x.
No, we won't get it. You're making a mistake here. Look at here. There is a by 2 here. You see this by 2? Okay, let me write it more clearly. Okay, so x is equal to let me remove the 2 outside. So this too small. So minus x by 2 here, minus this by 2, and it will come from this by 4 here. Correct? Does this look correct? Now tell me when you take the what happens to the other side of LSH, what will we get? Will I get 2x or will I get something else?
2x.
Is it 2x? See, there's a by 2 here. This becomes an x by 2 here. What is it there? If I take this to the left side, what will I get? What will happen if I take this x by 2, this x by 2 to the other side?
So x plus x by 2.
Yeah. How much is that? X plus x by 2 is how much?
So 3x by 2.
Exactly. So 3x by 2 is equal to what? What will I get? 100 into 100, this 100 into 100 into 101 by 2. So I made a mistake. 3x by 2. And then what else? That plus. Let me remove these to make it more clear. Okay. Yeah, that plus what? Can someone tell me the term? Very good.
Plus 100 into 100 and 1 by 4.
Exactly. Now can you simplify this more? I can take the 100 and the 101 by 2 outside. So this is 100 into 101, sorry, by 2 outside, and then 100 into 101 by 2 I got removed. So then I'll get 100 from this first thing, and from the second thing I will get another half. Okay. So I got 100 into 100 by 2 into 100 plus half. Okay. And I can take the 3 below and the 2 up. So let me multiply both sides by 2. So if I multiply both sides by 2, I'll get 3x is equal to 100 into 101 into 100 plus half. I just multiply both sides by 2. Okay, correct? Which is equal to, what is this? 100 into 100 does that do? This is equal to 100 into 101, okay, into 2 times 100 plus 2 times 100 plus 1 divided by 2. Okay. Now tell me what is x from here? What is x from here? When I take the 3 to the other side, what will I get? Will I get 1/6? 1/6 times something? So 3x is equal to 100 into 101 into 201 by 2. So I'm taking the 3 to the other side. What will I get? 1/6. Will I get 1/6? 1/6 of what?
Yes, sir.
Yeah. 1 by 6 into 1 by 6 into what? 100 into 101 into 201. Okay, so this is exactly marking the formula. 1/6 n into n plus 1 into 2n plus 1. Okay, is this clear? How we got this formula for 1 plus 2, 1 square plus 2 plus 100 square? Is exactly
Yes,
becoming
sir.
1/6 into 100 into 100 plus 1 into 200 plus 1. Okay, so let's stop here. We can continue next time. Okay, thank you so much. Bye.
Thank you, sir.
Thank you,
Bye,
sir.
sir. Thank you, sir.
Bye bye.
Thank you.
Bye, sir.
Bye.
Bye, sir.
sir.
Bye bye.